question now. So what was
Yes.
the question?
Um, it was like we were doing a table something.
Yeah, I'm doing it. I'm just finding it out. So there's that point. Okay, is this the one? Oh, so this is the one, right?
Yes, sir.
Yeah, so this is the question you are seeing. So let's take another question, right? So let's
Yes, sir.
take a different question and let's try to find out the cross products. So we have yeah, we have okay, so let's write A as 2I plus 3J minus 4K, and then B is let's say 3I minus 2J plus 3K. So these are the two vectors, and we want to find out their cross product, right?
Yes, sir.
So we already know what is AX, what is AY, what is AZ. That is 2, 3, minus 4. From here we have already BX, BY, BZ. So that is 3 minus 2 and 3. And then we have to find out A cross B. So A cross B, we know that that would be the determinant of this matrix, which is written as this one. So there are hats, right? And then
Yes.
we have AX, AY, AZ, and then we have BX, BY, BZ, right?
Yes,
And
sir.
then if we take this one, so let's say we take this column and this row. So this is discarded, right? So if we
Yes.
take I1, then this is discarded, and then we have this one and this one. So AY, BZ minus AZ BY, right?
Yes, sir.
And then we take another one, right? So then we take J. So this one discarded and this one discarded. So what is remaining? This one and this one. So minus J is always written, the middle one is always written with minus. So J
Okay.
and AX BZ minus AZ BX. And then last one plus K hat. So for K hat, we have to discard the rows and corresponding columns. So this one and this one. So we have this and this. So with K, we have AX BY minus AY BX. So this would be the cross product, right?
Yes, sir.
So we could have put the values earlier, but now we have got this thing. So let's put the value in here. We can start with this only, right? We can only start with 2, 3, minus 4, and 3, minus 2, and 3. We can start from here and then do all these process. But then we will
Yes.
get the same result, right? So now let's put all these values. AY is 3. BZ is 3. And then minus AZ is minus 4. And BY is minus 2.
Yes.
So this is the one. And then JAX is 2. BZ is 3. AZ is minus 4. And BX is 3. And then we have K. So AX is 2. BY is minus 2. And then minus AY is 3. And BX is 3. So everything we have remembered. So let's solve this part.
Yes.
This is 9 minus plus and minus. So minus 8 and then minus j hat. This is 6 minus plus 4, 12. And then we have k. This is plus and minus, so minus 4 and minus of 9. So what we'll get? We'll get this is 1. So I hat, this is 18. So 18j hat and minus 13 k hat. So this would be the cross product. Clear?
Okay, sir. Yes, sir.
Yeah, so just note down this part, right? And then we'll
Yes, sir.
start.
Okay, sir.
Yeah, please note this one down and then we'll talk about the next topic.
Okay, sir.
Yeah, whenever you have noted, please tell me.
Yes, sir. Yes, sir. We can continue.
Okay, so now the next topic, because we diverted from the chapter, so the next topic is equilibrium, right? And
Yes, sir.
let's understand that. Right, so what is an equilibrium, right? So what do we understand by equilibrium? You have learned this part in your 11th standard. What is equilibrium?
Um, it's like it's like opposing forces balance something.
Equilibrium means that when all the forces are canceling each other out. So something is pulling someone in right hand side and equal forces applying in the left hand side, upward and downward. So when every forces are balancing each other, right?
Yes,
When
sir.
every forces are balancing each other. So let's say this force is acting towards this direction, this force in this direction. So this is F1, this is F2, this is F3, and this is F4. So
Yes, sir.
at this point, F net is 0. So all the forces are balancing and force is 0 at this point, right? This right
Yes.
is balanced by this left one, this upward is balanced by this downward. So this is called equilibrium condition,
Okay, sir.
right? But in electrostats, we have two kinds of equilibrium, right? We have two
Yes, sir.
kinds of equilibrium, and those are right. So equilibrium is, what is the definition? So F net is 0 for equilibrium, right? If F net is 0, then this is called equilibrium.
Yes, sir.
So F net, which is F1 plus F2 plus F3 plus F4, all the forces are cancelling each other out, and this is giving you 0. So this is called equilibrium. Give me one moment. So there is
Okay,
this
sir.
mail that I have to see. Oh. Okay. So this is what we call equilibrium. But in electrostats, we have two kinds of equilibrium, right?
Yes,
So
sir.
kinds of equilibrium in electrostats. Right. So there are two kinds of equilibrium. One is that one point, so only a point is at equilibrium. Okay? So only a point is at equilibrium.
Yes, sir.
And then we have the system. So whole system, right? Whole system is at equilibrium.
Yes, sir.
So these are the two cases that we will understand, right? So first thing is that only a point is at equilibrium. So let's say that let's do a question, and then it would become easy to understand, right? So we
Yes,
have
sir.
two charges of magnitude, let's say Q and plus 4Q are separated by distance L, right? So there are two charges Q and plus Q, and they are separated by a distance L. So find the position of the third charge, let's say Q, which should be kept in between the charges so that the point or the charge Q is at equilibrium.
Yes, sir.
So there are two charges which are there, and we place another charge, third charge Q, and we have to find that at what position we have to place this charge so that it is at equilibrium, right? That is the question. So in this one, what is the case that we are using? What is the case that we are applying? The first case, right? So this is case first. One point is at equilibrium. Right. So this is one such case. Now let's understand this diagrammatically, right? So let's make a diagram, and then this would be clear. So we have this charge plus Q, and then we have another charge plus 4Q. And and the separation between them is L, right? So separation between them is L. And now we are placing another charge, right? We are placing another charge Q at here. So we are placing a plus Q charge in here. Now, what we have to find that what is this X so that this charge is at equilibrium. So whenever we are talking about equilibrium, so what is the parameter that we are inferring to? What is the parameter that we are talking about whenever we are talking about equilibrium? What was the definition that we use? What was the physical quantity that we talked about? Whenever we were talking about equilibrium, so what was the physical quantity that we talked about?
It's I just wrote it.
So don't stress yourself. So we talked about force, right?
Yes, F net is
F net equal to 0. So which means that if this thing is at equilibrium, if this point is at equilibrium, which means that all the forces acting on this thing would be cancelling each other out, right? That
yes,
is
sir.
the idea.
Yes.
So at this point, how many forces are acting on this thing? How many charges are there? For this point, how many extra charges are there?
One extra charge.
For this one, there are two, 1 and 2. There are two charges. So
Yes.
how many force would be there?
3.
So there are two charges. So there would be two force, right?
Oh, yes, sir.
So there are two forces and they would be cancelling each other out. So we have to just write that part, right? So let's say this is point A, this is point B, and this is point C. So we have to find out, right? And if let's assume that this is X. So what would be BC? Can you tell me? What would be BC? What would be BC? If this is X, AB is X, what would be BC?
2x.
Why that would be 2x? Total length is L.
Yes,
Total
sir.
length is L. This one is X. From here to here, that is X. So what would be the rest part? If total is 4, right, you have taken 1. So how much is remaining?
3.
So you have to subtract this one with this one, right?
Yes, sir.
So what would be this thing?
So it's uh,
Total
L
minus whatever you have consumed or whatever you have covered, right?
minus x.
L minus X. So this is the remaining length, right? Good.
Yes.
Okay, so now we will talk about two forces, right? In Coulomb's law, we have two charges and then we talk about the force between them. So this is the test charge, right? We are calculating the force on this thing. And let's say if I talk about this one charge, right? So if I talk about this one charge, this small q charge. So on this point, what would be the force? That would be repulsive or attractive. Due to this charge, what would be the force? Repulsive or attractive?
Repulsion.
Repulsive. So because these are positive, so they will repel. So where should be the force? Left or right due to this one? Where would be the force? If it is repulsive at this point, which means that this is repelling this charge. So where should be the force? Left or right?
Right.
Right, absolutely correct. So this is, let me choose another color. So this is, yeah. So this is, oh, this is not shown. No, yeah, let's take this. So this is FQ charge. Clear?
Yes, sir.
Now, this force we have taken into account. Now this charge is remaining. So this is plus 4Q, this is plus Q. So what kind of force there would be? Attractive or repulsive?
Um, repulsive.
Repulsive. So where would be the force, right or left?
Right.
This one on this one.
It's left.
Left. So this is F4Q. Right. Clear?
Yes, sir.
So we have two
Yes, sir.
diagrams, right? We have two diagrams. This one is, what is this? So this is plus Q and this is plus Q. Distance is X and this is the force that we have saved. And we have another diagram. So this is plus 4Q. This is plus Q and distance is L minus X. And this is the force F4Q, right? So this is F4Q, this is
Yes.
FQ. And this point, this B point is at equilibrium, which means that this should be equal to this, right?
Yes, sir.
So because point B is at equilibrium. Which hence we have force Q that would be equal to F4Q. If these are equal, then they will cancel each other out, right?
Yes, sir.
Okay, so can you tell me what would be, using the Coulomb's law, what would be FQ? Please tell me what would be FQ. Let me see if you remember the Coulomb's law or not.
Um,
What was Coulomb's law?
it's Q1 into Q2 divided by R.
R square. Yes, absolutely correct. So K Q1 Q2 by R square. Right.
Yes, sir.
So you have K and what is charge 1? What is Q1? So FQ, let me write it in here. K, this charge by separation square. Right.
Yes, sir.
And then what would be F4Q from here? Can you tell me? Again, K, Q, 4Q, and L minus X square. Correct?
Yes, sir.
So let's write all these values. So K, Q, Q divided by X square, and then K, Q, and 4Q divided by L minus X whole square. So this Q and this Q cancels, this Q and this Q cancels, this K and this K cancels. So what do we have? So we have 1 by X square, that is 4 by L minus X whole square. So what we will do is that we'll take this thing in the left hand side and this thing in the cross multiplication. And we will take square root on both these sides. So taking square root in both these sides. So what do we have? So we have L minus X, that is plus minus 2x, right? Because root 4x square is plus minus 2x. So first we will take the negative value. So L minus X right? We'll take the negative one. So we have, let's say A, that is minus 2x. So L equals to minus 2x plus x. So L is minus x, so x is minus L. Length cannot be negative, so this is discarded, right? Then we have B part,
Yes, sir.
which is positive. So L minus x is 2x. And you take this the other side, so 2x plus x. So L is 3x. So x is L by 3. So the distance that we have to put, so this distance from here, this would be L by 3 distance from A, right? So the
Yes, sir.
answer is that we have to put L by 3 distance away from A. So that is the answer. Is it clear? So this is the equilibrium at one point.
Yes, sir.
Okay, so yeah, please note down this part and then we will understand about equilibrium at multiple points. System is at equilibrium. So that part we'll talk about. But before we do that, please note down this part.
Okay, sir.
And whenever you want me to scroll down the screen, please tell me.
Okay, sir. You can scroll down, sir.
Okay, so So this is the actual diagram, and these parts are individual forces, right?
Yes, sir.
Yeah, whenever you have noted, please tell.
Yes, sir. Okay. Yes, sir. Finish.
Finished. So the next thing that we have to understand is that what happens when we have all the 3 points, right? So system is at, okay, so let us write that question. So the question is that, again, the same kind of question, but the only difference is that, so the difference that we have is, yeah, so two charges, again, Q and plus 4Q are kept at a distance of L with each other. So find the nature and distance, or we should write it position And the third part, which is the magnitude of the third charge, which should be kept in between these two charges so that whole system is at equilibrium. So now we have three questions. We have three questions: nature, position, and the magnitude of the third charge. And the relation that they have said that the whole system is at equilibrium. So this is the information that they have given. Right. In the previous question, they only asked about the position. Right. This was the only thing that they asked. Right.
Yes, sir.
And now they have given this thing that whole system is at equilibrium, and they are asking that what would be the nature, position, and the magnitude of the third charge. Right. So let's do this thing. So let's first make a diagram, and let's talk about the nature. So case first. So case first is nature. So let's understand this, what would be the nature. So we have two charges, and this is Q, and this is plus 4Q. Right.
Yes, sir.
So what could be the nature of the charges, right? What do you mean by nature of the charges? It can be positive charge, it can be negative charge, right?
Yes, sir.
So let's take first condition that charge is positive. Third charge. So first condition is that third charge is positive, which means that nature is positive.
Yes, sir.
Let's try to fit this thing in our question. So we have put the third charge, right? We are not talking about the distance or whatever. And we have put this charge, and this is positive, right? And
Yes,
they
sir.
are saying that whole system is at equilibrium, which means that in here, so this is at equilibrium. This is at equilibrium, right? And this is also at equilibrium.
Yes, sir.
So whole system is at equilibrium means that all the charges are at equilibrium, and I have taken the positive charge. So let's see this case. So let's pick this point. So let's pick this test charge. So this is the test charge. What would be the force due to this thing? What would be the force? Right or left? We are calculating the force on this thing.
Yes, sir. So left, mean
Left.
right.
Mean
Or
right. What? So we are calculating the force on here due to this one. So will that be attractive or repulsive?
it's
What would be
repulsive.
the repulsive? So this is left. So this is FQ, right? What
Yes, sir.
about due to this one? This is plus 4Q, and on this one, where would be the force? Attractive or repulsive? Both
So
are,
could you repeat it?
yeah, what kind of force would that be? This is plus Q, this is plus 4Q. So what kind of force on here? Attractive, repulsive. What kind of force would that be in here?
It's repulsive, right?
Repulsive. So right or left?
Um, right.
Towards this one. So that would be attractive, which means that this is attracting this plus Q charge. Is it attracting this
No, sir.
plus? So this is repelling. So this is the direction
Repul yes, sir.
F4Q. Okay, this one is done. Now let's come to this point. So we have this plus Q charge and we are calculating the force on this thing due to this one and this one. So let's say due to plus Q, what would be the force, right or left? In here, what would be the force, right or left? Due to this one.
It's left, right.
Right, because this will be repel this thing, plus plus, so
Yeah.
repelling. So this is FQ. Due to this one, right or left?
What should I do there?
Due to this plus 4Q1 on this point.
It's left, sir.
Left. So this is correct. F4Q. And now let us come to this point. So at this point, what would be the force due to this one, right or left? Forget about this thing. We are only talking about this one and this one. So due to this one, right or left?
Left.
Left means that this plus Q is attracting this thing. Is it this plus Q will this attract this thing or repel?
Repulsive.
Yeah, so this plus Q will try to repel this thing. So this will be in here.
Left. Right. Yes, sir.
Again, this plus small q. So this will also try to repel this thing. So this is FQ. Is this point, are these points clear to you? Are these points clear?
Yes, sir.
So let's say that this is point A, point B, point C. Right. Let me write it in down. For consistency, let's write it in. So we see that this point is at equilibrium, right?
Yes, sir.
This is at equilibrium. What about this one? Is this at equilibrium?
Yes, sir.
No, both are left. Both are going in the left direction. So there is no balance. There is
Okay,
no
sir.
balance force, right? So this is not at equilibrium. So this is not at equilibrium. This one is also not at equilibrium, right?
Yes,
So
sir.
due to plus Q charge, point A and C are not at equilibrium. Hence, nature cannot be positive. Right, this is one thing. Okay, is this part clear?
Yes, sir.
So let's talk about the second case then. Let's talk about B. B part, which is plus charge is, so charge is negative. Third charge is negative. Right, which means that nature is negative. So let's try to fit this scenario. So again, we have plus Q and plus 4Q. And we are putting a charge which is minus Q. and the whole system is at equilibrium. So A, B, and C. The whole system is at equilibrium. So this is at equilibrium. This is at equilibrium. And this is also at equilibrium. So let's check this case, right? If it is true or not. So let's start with this one. Let's start with point A. So point A, there are two charges, this one and this one. So at point A, due to minus Q charge, force would be attractive or repulsive. What would be force due to minus Q?
Attractive.
Attractive, so right or left?
So right, sir.
Right, absolutely correct. So this is FQ, right? Whenever we take the direction, so we don't write the positive or negative thing. So whenever we have taken into account the direction, then it takes into account of this negative charge. Okay, now at A point due to 4Q, attractive or repulsive? What would be that?
From A point to.
So at A point due to this C point, 4Q charge, the
Yes,
force
it's
would be repulsive. So this is in this direction.
Yes, sir.
Clear?
Yes, sir.
Okay, now let's come at this point. So due to this Q charge, force would be repulsive or attractive at this point.
Attractive.
Attractive, right? So this would be towards left. And due to
Yes,
this plus 4Q charge, force would again be attractive. So in this direction.
yes, sir.
Now let's come at this point. So at this point, due to minus Q, this will try to attract. So this is F capital Q. Clear?
Yes, sir.
And then this plus Q will try to repel this thing. So this would be. Okay, so now we have this diagram. Can you tell me, do we have any non-equilibrium condition? Any non-equilibrium condition?
No, sir.
So everything is at equilibrium, right?
Yes, sir.
So this tells our answer that nature should be, Q should be positive or negative. What should be Q?
It's negative.
Negative, right? So which says that Q should be negative.
Yes, sir.
Okay, so this completes our first part. Now we will talk about the second part, but we will borrow this diagram. So let's borrow this diagram. We will use this diagram again. Right, so Control C. So then we have the second part. Second question is, position. What is the position? Right. So let's bring this diagram in. Okay. So to find out the position, what we will do is that we will let's erase this part. So we will use the condition of equilibrium at B. So point B is at equilibrium, right?
Yes, sir.
So which means that we know already the condition FQ that is equal to F4Q. And this distance we have chosen X. This distance is L minus X. And the total distance Right, the total distance was this total distance was L. Okay, so FQ, we already know what would be that. What would be FQ? What is this FQ? Yeah, this is KQQ divided by X square. Am I correct?
Yes, sir.
And F4Q, due to at this point, due to this charge, that is K and 4Q, and then Q divided by L minus X square. So Q and Q and Q and K and K, all these cancel. So we got the similar result as the previous one. So we will directly write that answer would be X equals to L by 3. So this should be at L by 3 distance. Is it clear?
Yes, sir.
So this is second part, and then we will talk about the third thing, which is the magnitude. So what is third thing, case third? What is the magnitude? So let's calculate the magnitude. Again, we'll use the same diagram. But what we will do in this case, we will use the idea of equilibrium. So this is X, this is L minus X, and the total distance is L, right? So we will use the condition that point A is at equilibrium.
Yes, sir.
So what does it say? It says that F4Q, that is equal to FQ. Correct?
Yes, sir.
Now, can you tell me what is F4Q? By looking at this diagram, can you tell me what is F4Q? Leave everything, leave every other thing, right? Leave everything and then only focus on A and C point. Forget about the other things, only focus on A and C point. What are the charges? What is the distance? So that will give you have to apply the Coulomb's law. Yeah. Whenever we are talking about Coulomb's law, so we have to think two charges. What are the two charges? That is Q and that is 4Q. These are the two charges. What is the length between them? Separation.
It's X plus it's L.
S. It's L. Absolutely correct. So what would be the force? What would be the force? That would be simply K Q 4Q by L square, correct?
Yes, sir.
So this is A to C, A and C. Now let's try to find out A and B. So we have Q charge, we have what is this charge? Q, and then separation is X. So what would be this thing? FQ is simply KQQ by X square. Remember, I'm not writing the negative or whatever charges, right? Because I have already considered the direction. So whenever you consider the direction, you don't need to write the negative thing, right? So yeah.
Yes, sir.
So let's put these values. So this is K Q 4Q divided by L square, and this is K Q Q by X square. So Q and Q cancels. K and K cancels. So Q is how much? That is x square into 4q divided by L square. Right.
Yes, sir.
So what was the value of x? X we have already calculated. What was the value of x? L by 3, right?
Yes, sir.
So 4q divided by L square. So this is L square, 4q divided by 3L square. L square cancels. So we have q, which is 4q by 9. So this is the magnitude. And we know that as we know that q is negative. So then we have to write q is minus 4q by 9. So this is the magnitude. Is this part clear?
Yes, sir.
Okay, so please note down this question, right? So please note down from here. This question is very important, right?
Okay.
So this talks about the
Yes,
system of charges at equilibrium.
yes, sir.
Yeah, so please tell me whenever you need me to scroll down the screen. Yeah, whenever you need me to scroll down the screen, please tell.
Yes, sir. You can scroll down, sir. You can scroll down, sir. You can scroll down, sir.
Okay. Yeah, so this is.
Yes, sir. Yes, sir. Over.
Yeah, okay, so equilibrium, right?
Yes, sir.
Yeah. So now there is another question. So now we connect this equilibrium with another physical quantity, that is tension, right? So this equilibrium can be connected with tension. So we have equilibrium plus tension. And these there are some questions based on these ideas. So there are questions based on equilibrium plus tension. And what is that question? So you will be given, let's say we have this rigid wall, right? and two charges are hanging, and they are making equal angles, right? So let's say this is one charge, and this is another charge, and they are making equal angles, right? So let's say this is the vertical. So they are making theta angle, and this is also theta angle, right? And you have, so this is the
Yes.
string, and these charges have equal magnitudes, right? These charges have equal magnitudes, and the question is that you have to find out what is this separation, right? What is this separation so that these charges are at equilibrium? So that is the thing that you have to find out. Is it clear?
Yes, sir.
Okay, so do we have, yeah. So if this is a theta, this is the string, right? And let's say the mass of these two charges are, right? What are the masses? So its mass is m, and its mass is also m, right? So these are the masses. Okay, so what are the forces that are acting on this thing? What are the forces? So one would be this tension, right?
Yes, sir.
Tension due to this string, right? And then we have what is, so let's say this is the vertical, this is the vertical, and this is the same tension, right? And the other force
Yes, sir.
would be this gravity, that is mg, right? Downwards. In here we have also gravity, that is mg, downwards. And what is the other force that you have? These are positive charges. So what is the other force that you have?
Yes, sir.
You have one force that is tension, other force is gravity. What is the other force? Can you tell me about that?
Um,
What is the other force that you have?
Nothing and gravity. I'm not sure, sir.
So the other force is Coulomb force between this Q and Q. So there are three forces, right? One is tension due to string. Then you have gravity, and then you have Coulomb force. Clear? Is it clear?
Yes, sir.
So what would be the direction of Coulomb force at this point? What would be the direction? Up, down, right, left. What would be the direction?
Yes.
No, I'm asking what would be the direction of the Coulomb force? Oh,
It would.
please. Yes, where would be the, where would be the Coulomb force? Who got disconnected? Yes, Thameem, you got disconnected, right?
Oh, yes, sir. Sorry, sir. Hello, sir. Can you hear me?
Yes, yes. Can you hear me, Thameem?
Yes, sir. I can
Yeah,
hear you, sir.
why? Sorry, please. Yeah, I can hear you. Please don't reach it. So that happens. Yeah. So I was asking that there are two charges, Q and Q, plus Q and plus Q, right? And they would experience the Coulomb force, right? Force due to the charges, right? So
Yes,
Coulomb
sir.
force, and what would be the direction if I'm talking about this charge? So what would be the direction of the force? Up, down, right, left. What would be the direction? Force would
Um,
be repulsive, so that would be left,
yes, sir. Left.
right? So these are
Yes,
the forces.
yes,
Mg tension FQ. So this Mg tension is with some angle. So we can resolve this
sir. Can you repeat
tension
again?
in two parts, right? Right?
Yes, sir.
Yeah. So I'm saying that mg is along the axis, y-axis. FQ, the Coulomb force, is along the x-axis.
Yes, sir.
So these are on angle. So we can resolve this tension in two parts, right? Clear?
Yes, sir.
So if this is theta, so this angle would be theta, right?
Yes, sir.
And if this is theta, so what would be this component? This is with theta. So what would be this component? With theta, what is the component? With theta, you have horizontal component. So what would be this component?
Um,
That thing we have already learned, right? So this would be t cos theta. Clear?
yes, sir.
Is it clear?
Yes, sir.
And this would be t sine theta, right? Is it clear?
Yes, sir.
Okay, so now because we are talking about equilibrium, so this point is at equilibrium, right? So let's name this point as some A point. This is A point. Let me choose a different color. So let's call it an A point. So this is point A, this is point B. So point A is at equilibrium, which means that all the forces will balance. So vertical force, vertical
Yes,
part
sir.
will balance. Vertical part, what is the vertical part? What are the vertical parts? Cos theta. Clear?
Theta. Yes, sir.
Yeah. And then you have horizontal part. They would balance each other, right?
Yes, sir.
So what is the horizontal part?
And
Yes. Mg is the vertical part, right? These are vertical part. This is horizontal. So
yes, sine
FQ,
theta.
yeah, FQ is T sine theta. So this
Yes,
is the horizontal part. And why they are equal? Because they are at equilibrium. So they will balance each other out. Now what we will do is that we will divide. So dividing equation second with first. So what we will get? We will get FQ by mg, that is equal to T sine theta by T cos theta. So this part cancels out, and we have FQ, that is mg tan theta, right?
yes, sir.
So what is FQ? How much is this FQ? Separation is D, right? Separation is D and charges are KQ. So FQ would be KQ divided by D square. So that is FQ, right?
Yes, sir.
So FQ is KQQ divided by D square, and that is mg tan theta. So we have D square, which is KQ square by mg tan theta. So D would be root of KQ square by mg tan theta. So this would be D. Is it clear?
Yes, sir.
Okay, so this was the question. We have to find the separation between D. So the question was find D so that the charges are at equilibrium. So please note down this question, right? Please note this one down, and if you have any doubt in this one, please tell.
Okay, sir. You can scroll down, sir.
Yeah.
Done, sir.
Okay, so we'll stop here and you have your class assessment, right? So yeah, please log into your learning account and then please take that test, right? So yeah,
Yes,
please
sir.
take that test. So I will stop here, right? And in the next class, we'll talk about Coulomb's law in vector form. So that is one, the important one. Okay,
Okay,
so
sir.
Allah Hafiz, Thameem. See you in the next class. Allah Hafiz.
Bye, sir.